Hello, this is Timber again. We're going to get started today with an A+ certification. And to get started, we're going to talk about the development of the computer. So the very first computer was called the abacus. And the way it worked is you move the little beads around to perform your addition. So basically computers, that's all they do is add and subtract. They just do it very, very fast. And there are some mathematical shortcuts through a secondary chip that was added to speed up the mathematical operations, some of the more advanced ones, to do some scaling, some faster operations. And that processor is called a math coprocessor, and it goes along with the main processor. But basically computers just add and subtract, but they do it very fast. And they do it in such a way where we group some operations to perform, multiplication and addition, which are basically all of the mathematical operations we can do, even integrals, can be boiled down into addition and subtraction. It's just how you're performing the addition and subtraction. So with respect to the abacus, we have the upper deck across the top here, and then the lower deck across the bottom. So the lower deck we call the frame, and then we have beads and rods, and you just move the little things around to perform the mathematical operations. So we also had an analytical engine, and this is what this guy looked like, so a more advanced version. So the very first electrically driven computer was used what we called punch cards. So this is an actual punch card. And notice that this one doesn't have any numbers on it. You just stacked them up in order. So if you tripped and fell and spilled the cards, you had to go figure out what order they went in. It used to happen to people. It was a big deal. It would take them weeks or days to figure out the correct order. Sometimes they just started over. So you had to punch the cards and then process them through the computer to get your answer. So the digital electronic computer, in 1939, we had Antonov Berry built the computer. ABC was his initials there. In 1943, we had the Colossus 1. Because of its size is why they called it the Colossus 1. And in 1945, we had the Electrical Numerical Integrator and Computer, ENIAC. So it was one of the very first real computers. And then the other ones were real computers, but this was doing a lot of work. And in the 60s and 70s, we had the golden era of the mainframe computer. Some milestones of modern computing. In 1971, we had the first 4-bit multiprocessor. So you will see test questions about this, by the way. You need to know what these were. So you're going to see there are some in the pool of questions. They'll come up differently. So you'll see some questions about the Colossus, the ENIAC, and the 4-bit for sure, 16-bit. The first PC, so you need to be familiar with these dates, the first Pentium, and I think that's about it. And in fact, there's very few times I'll see that Pentium question come up. So just be familiar with that. So let's finish covering this. In 1971, we had the first 4-bit multiprocessor. That was a 4004 1 megahertz, and man, that was a sweet time. We only had to deal with the 4 bits. You could pretty much get all of that in your head pretty easily. It was pretty easy to know everything and learn everything, where today they're just incredibly complicated. You can't even keep up with just a memory space. So we need tools and stuff to do things for us today, where back then you could look at the whole thing and know every little memory space and what went where. It was a sweet time. Even the 8-bit multiprocessors or 8-bit processors were pretty manageable to keep everything in your head. The first 16-bit came out in '78, and it was a multiprocessor, or a microprocessor, sorry, 8086, and the coprocessor 8087. So the coprocessor is what I was describing before. It manages the mathematical operations. So it performs advanced division. You can give it, 2 dividends or something like that, a dividend and the operators that you want to do for different mathematical operations, and then it would go and process them for you. It had all the circuitry built in to do that kind of thing. You could tell it which kind of operation, give it the operands, and it would go and perform it for you. You didn't have to do anything. So it was pretty fast. It also was used to speed up. So if you are a CAD designer or something like that, or if you're an engineer and you had an engineering program and you want to go compute, so you feed it this drawing, you create this drawing, and say something like AutoCAD, and then you want to go and have it give you back the inflection points or things where you need to stiffen things, or where you can, certain numbers that would tell you where things were weak and where things were strong. you know, their inflection points in mathematics will give you different things depending on the application, right? So the math coprocessor was used heavily for computing that kind of stuff. So that's what it was for. And in the early days, they would actually burn these out. So the chips were all made with math coprocessors built in them. So like you would get motherboards that had the math coprocessors on them, they would just burn them out. And then they changed it to be where it was embedded inside of the chip itself, the actual processor. And they would go in and electrically burn the coprocessor out for marketing. So you had the Pentium M, the mobile one, which didn't use as much power. So they literally just burned the microprocessor, the coprocessor, the math coprocessor out of it for marketing. So they had different ones. So the little light processors didn't have the coprocessors in them, so they wouldn't use as much power. And it could still do all of the same operations, but it just took longer, like in microseconds, fractions of a second. Depends on how math intensive your operation was.